All right, good morning, everybody. I think we can get started. My name is Ayaz Minhas. I serve as Privacy Policy Manager, Artificial Intelligence for Meta Platforms, Inc. Today, I'm joined by my colleagues to talk about an emerging topic in the fields of privacy and AI, privacy-enhancing technologies, and as these technologies are applied in the AI space, privacy-preserving machine learning. Now, I first want to begin this session by thanking the conference organizers, the attendees, and the co-presenters. It's really an honor to be attending here in Rio with this elite community of professionals. Now, as data protection practitioners, I think we're all aware of the large legal and regulatory changes in the area of data privacy. Here in Brazil, you have the LGPD. In Europe, you have the GDPR. In the United States, you have many state privacy laws and talk of a federal privacy law. With respect to AI, you have a number of new governance frameworks for AI globally, including from the UK, Japan, and Singapore. And in the European Union, they're continuing to craft the EU AI Act and its risk-based approach to artificial intelligence. Now, alongside regulation and across industry, privacy-enhancing technologies will likely play a key role in balancing privacy interests of users with the use of data, especially with the deployment and development of artificial intelligence assets. Generally speaking, privacy-enhancing technologies are technologies based on advanced cryptographic and statistical techniques that help to minimize the data that a company can collect, view, access, process, or share. Recently, you've seen global efforts, including efforts by the United Nations, the G7, the OECD, and the Global Partnership on Artificial Intelligence to study these technologies and their impact on industry. So today, I have some excellent colleagues that are going to share their expertise on privacy-enhancing technologies. Joining me here are David Lear, Privacy Policy Manager at Meta, Renchao Jiang, one of our software developers for social impact, Osama Berkey, a software engineering manager for AI and ML. We're also joined by my colleague Daniela Rojas from CMind's Eon Resilience Labs, one of our policy partners for Open Loop on policy prototyping. Thank you guys for being here today, and thank you to the audience for attending. So Renchao, I'm going to begin with you. Renchao is going to start out talking about a core privacy-enhancing technology, but I'm going to allow her to introduce herself. Renchao, could you please say a few words?
Yeah, hello everyone. My name is Renchao. I'm a software engineer at Meta. I'm working on privacy enhancement technology, or PET in short. Particularly, I'm researching technical solutions that will allow external researchers to analyze sensitive data while they are not actually accessing the underlying data.
Wonderful. Now, Renchao, I know one of the big privacy-enhancing technologies you've worked on is differential privacy. Could you explain to the audience what differential privacy is?
Sure. When people say a computation protects individuals' privacy, they are usually thinking about algorithms whose outputs do not reveal any information that is specific to any individuals. Differential privacy formalizes that thoughts as a rigorous mathematical framework. The output of differentially private algorithm is approximately the same whether the individual's information was used or not. Differential privacy analysis protects the privacy of the individuals in the data sets by introducing a carefully calibrated random noise into the output statistics, a privacy parameter, or more accurately, a privacy loss parameter, which is usually notated as epsilon, controls how well each individual's information needs to be hidden, and consequently, how much random noise should be introduced during the differentially private computation. The smaller the epsilon is, the stronger the privacy protection is. Differential privacy algorithms are known to exist for a wide range of statistical analysis. With mathematical rigor, one can confidently prove that a computation is differentially private or not.
Wonderful, and thank you for that explanation. So how would you say differential privacy is different from other anonymization techniques, if at all?
There are several. Differential private is robust under composition. That is, it provides a way to bound the accumulated privacy risk when multiple analyses are performed on the same individual data. Differential privacy is robust to whatever auxiliary information that external people may utilize in their attempt to learn individual information in a data set. Differential privacy is robust to a wide range of potential privacy leakage, even including those that are unknown at the time of deployment. In contrast, many traditional approaches, for example, aggregation, suppression, reduction, fail to acknowledge that people could query the data multiple times, or they could use information obtained outside of the system in their attempts to learn private individual information from a data release. Actually, there are many famous examples which demonstrate that the data set that has been traditionally de-identified can often be successfully re-identified.
Now, I want to focus on that idea that traditionally de-identified data can be successfully re-identified. Can you give us an historic example of that?
Yeah, one of the early but very famous example is that in the late 1990s, the Group Insurance Commission in Massachusetts in the United States allowed external researchers to access its anonymized hospital visit records from the Massachusetts state employee. Massachusetts Governor William Weld reassured the public that the patient's privacy was protected because names and other personal identifiable information, or PII, has been removed. A student from MIT later became a professor, proved that Governor Weld was wrong. She actually obtained demographic information about Governor Weld by requesting a copy of the voter registration record, which was available to public for a small fee. She found that just one record in the anonymized medical data set that matches Governor Weld's demographic information. With that, she successfully re-identified Governor Weld for that anonymized medical data set. Following this example, more and more studies demonstrated that traditionally de-identified data set can actually be re-identified. And then people start to thinking about privacy protection from new angles, for example, via differential privacy.
That's great. And given that background, could you share some of the public work you've done with differential privacy?
Yeah. In early 2020, Meta released a data set which is designed to allow external researchers to study the distribution of URLs on Facebook and how users interact with them. The current version of the dataset summarizes the demographics of people who viewed, shared, and interact with these URLs shared on Facebook starting January the 1st, 2017. We've protected this dataset using differential privacy, which add well-designed noise to the data to provide precise guarantee that no significant additional information can be learned from the dataset about individuals, including whether a person is in the dataset or not. But at the same time, researchers can still use this dataset to uncover broad time series or group level trends.
Fantastic. Thank you for introducing to us that first example of privacy-enhancing technology. Now, I want to switch over to my colleague, Osama. Now, Osama, we've talked a bit about differential privacy, but I want to talk a little bit about PETs as applied to artificial intelligence and ML. Before we do that, Osama, could you please introduce yourself to the audience?
Thank you, Ayaz, and hello, everyone. My name is Osama. I am an ML engineering manager at Meta, and I support a team within the Responsible AI organization that researches privacy-preserving ML technologies. Prior to Meta, I was a senior director of engineering at a ride-hailing company in the Middle East and North Africa, Turkey, Pakistan region that was acquired by Uber in 2018. And back then was my first encounter with privacy in general, and especially GDPR.
Fantastic. Now, Osama, now that we've talked about one privacy-enhancing technology, could we talk about privacy-preserving machine learning? Why do you think what is privacy-preserving machine learning? What is it, and why do you think we need it?
Thanks, Ayaz, for the question. So PML, so privacy-preserving ML technologies. So these are sets of technologies that enable AI with privacy by design. So that means that if we build our AI or our ML models with these sets of technologies, it will automatically solve for one or several of the privacy expectations that we have, which means that we really allow to benefit from the benefits of artificial intelligence and machine learning, but with keeping a high bar for privacy. So let me give you a few examples of PPML technologies out there. So there's this notion of federated computation that includes both federated learning and federated analytics that is quite powerful because it allows to train machine learning models while keeping the actual data on device, right? So in this case, we can clearly benefit from enabling better experiences using machine learning, but we never have to bring the data into a centralized server. So how it works is basically that the devices contain the data and they will receive an ML model from a centralized server, and the device will then calculate what we call a gradient. And that gradient is aggregated along with the gradients from all the different devices that are participating in the round in a secured manner. And that final aggregation is then used to update the model. And then we keep doing that until we have a final output that we're satisfied with. Another example of PPML technologies is secure multi-party computation, or SMPC. And this one would allow two or more organizations to work together while limiting the information that either party can learn. So during that process, the data will be encrypted end-to-end, in transit, in storage, in use, which ensures that neither party can see each other's data. So let me give you a very, very simple example. So imagine here in this panel, we each have a number. So I have number 5. Ayaz, you have number 21, etc. And what we want is calculate the average of all of these numbers. So MPC would allow us to do that without neither of us nor any third party knowing exactly the numbers that individually we have. Right? So that's another example. A third powerful pet is what my colleague Rancho has been mentioning, which is differential privacy, which is both used in the context of aggregation in general, but also is very helpful in the context of machine learning, right? And in the context of machine learning, it really allows, it gives you that mathematical guarantee that any data point is not playing a significant role in the final ML model, right? And that model wouldn't be able to memorize any specific data point, which is quite strong mathematical guarantee of privacy. One thing that is worth noting is the fact that in practice, we would actually combine different pets together to achieve the level of privacy that we want for our specific use case, right? So, for example, I was mentioning federated learning. So these gradients that I mentioned that we would compute on device so that we aggregate them later, we could choose to run these aggregations in a much more secure manner through secure aggregation protocols. One might choose to do that in an ever more secure way by using trusted execution environments, or TEEs, to actually run these aggregations in a very higher bar of security, right? We can choose to add differential privacy, which even could come in different flavors. So our federated learning algorithms to add layers of privacy on top. So in practice, these pets would always be combined with each other to address the very specific use case that we have in hand and outcome a level of privacy that is desired.
So considering the technology, secure aggregation, and other points you have made, how does privacy-preserving machine learning link the concepts of privacy and security?
This is a great question. I think it links very well to the example that I just mentioned, right? So when we do this secure aggregation protocol, so this is a very good example of a security protocol that is used for privacy purposes, right? While differential privacy would be specifically used to avoid re-identification or member inference during or after the training, right? So let me give a little bit more color here. So a technology like multi-party computation would allow you to have an encrypted, secured aggregation. In the example that I gave earlier, which each one of us would have a number and want to get the mean, you would actually get the mean, which is the aggregation, in a way that is encrypted, secured, and you have a guarantee that no one will have access to these individual numbers, right? So that's security. For like, if you do it once, that's secure by design, and that's also private. Now, if you do several of these aggregations on the same data and you repeat this a large number of time enough, then you actually start losing the privacy aspect of things while keeping security, meaning that you will be able to reconstruct or re-identify the individual numbers from a large number of aggregations on the same data. Why? Because we have a notion here of accurate aggregation versus noisy aggregation, which guarantees privacy. And this is why actually we would have, for example, the concept of budgeting when we talk about federated learning or federated analytics. So budgeting is the fact that we want to keep a certain count on how many times a specific piece of information has contributed into calculating aggregations. And we want to ensure that we are choosing the participation in a very smart way, in such a way that we keep the privacy guarantee overall.
Excellent. And considering this question of training data that's part of an AI model, how can PPML ensure that a model is protected from a membership inference inquiry?
Yeah, so this is a great question, and it's a very new and an ongoing research field that is looking into whether it's possible to extract information from already a trained model. And without going into too much technical detail on the methodologies, but like there are several ways to do that. So member inference is one of them, and it's generally the most studied one because it's a gateway for other types of attacks. So member inference is trying to determine whether an input sample has been used as part of a certain training set. In other terms, it answers the question, given a certain data point and given a trained ML model, can I figure out whether this data point has or hasn't been used while training that model, right? There are other types of attacks, such as reconstruction attacks, where we could, for example, try to recreate samples or attributes of the data that was trained on. But overall, there's lots of research that is ongoing on the ability to measure level of privacy and how much a model could memorize either attributes or individual data points. And it's a field of research that is ongoing at the moment within the academic world.
Well, Osama, thank you for sharing that insight with this audience. It's great to hear your perspectives on what industry generally is doing with these technologies. So I want to shift gears a little bit and talk to my policy colleague, David Lear. David, we've talked a bit about these technologies. We've done a bit of a deep dive. Could you introduce yourself and then share how some of these technologies may be used to address privacy policy goals?
Yeah, sure. So thank you. For everybody here, I am David Lear. As Ais mentioned, I'm a privacy policy manager here. My background is actually in the life sciences, and then I did some work in civil society, doing some legal and policy research around machine learning. I was a lawyer for a bit, and now I'm at Meta. And at Meta, I work on developing some of our policy positions around new emerging areas. And One of the areas that I spent a lot of time thinking about is pets, is privacy-enhancing technologies and de-identification. So what I would like to do in my remarks is build on the great introductions to different pets that we had from Runchao and Osama, and try to think about how pets can inform different policy themes, different policy conversations that we're seeing emerge around the world. So the first one I'd like to talk a little bit about is personalization and the value that pets could bring to creating new personalized experiences. You know, small businesses especially, but businesses of all kinds, rely on personalized advertising to reach relevant audiences on limited budgets. And we think that pets show how that personalization does not have to be at odds with privacy. To give just one example of how we're seeing this play out, we are exploring secure multi-party computation, which you heard about earlier, to help advertisers understand how their ads perform in a more privacy protective way. So to build on what we heard earlier about secure multi-party computation, typically in a computation like the one I'm discussing, you would have to have both computing parties, for example, both Meta and an advertiser, know both who sees an ad and who then makes a purchase. We are exploring secure multi-party computation, though, to let both of those parties perform that computation without each of them knowing both pieces of that information. So that's one powerful way that pets can help create the next generation of personalized experiences. And then you also heard about federated learning or on-device learning, which also holds potential here. You know, that technology can help to train an algorithm using insights gained from processing data on an individual's device without sending information, for example, about who clicks on an ad or an email address to a remote server or cloud for processing. And as you heard earlier, a technology like on-device learning could also be combined with, say, differential privacy to yield even greater privacy protections. So all of these technologies could play an important role in driving forward personalization. Another policy area, though, where pets also hold a lot of potential is in research data sharing data with third parties. You know, many stakeholders right now are keenly interested in understanding how companies can share data with independent third-party researchers. And we have seen, through our experience, a lot of the benefits that pets can bring here. As just one example, our Data for Good team has been working on using privacy-enhancing technologies to share data with researchers. Particularly, they did a lot of work during the start of the COVID-19 pandemic. One example is they shared what are known as movement range maps. So these maps use differential privacy to provide researchers visualizations of aggregated county-level changes in people's mobility. So this then allowed our partners like government officials, like public health researchers, to do things like steer public health messaging to the right audiences, or to study how lockdowns impacted income inequality, as just a couple of examples. And then we also have had our Facebook Open Research and Transparency team, or our FORT team, that has used differential privacy to help with research data sharing. And you actually heard from Runchao earlier an example of this, the URL shares data set. So again, these are just two examples, but they show how technologies like differential privacy can be critical to enabling more data sharing with researchers. And then finally, the last policy area I'd like to talk about where pets hold a lot of potential is in equity and fairness. We have heard a lot of discussion throughout this conference so far and in others about the intersection of machine learning and equity, and pets have a role to play here too. One example is we are exploring how secure multi-party computation can help yield insights into whether people's experiences with our products differ across racial and ethnic lines. So again, yet another area where pets could really drive these policy conversations forward. One final set of remarks, though, that I'd like to make is about some things to keep in mind as we take these policy conversations forward. As we think about how pets could help with things like personalization or research data sharing. And that's that this area of privacy-enhancing technologies of de-identification is a very complex and challenging one. We've talked about a host of pets here today, but they are all different. They operate in different technological ways. They do different things, and they have different privacy risks that they help to mitigate. That creates a whole set of complexities to keep in mind in policy conversations. There are also some key tensions and trade-offs that need to be balanced in these policy conversations. One fundamental trade-off is between applying pets to de-identify data and ensuring the utility of data. Detailed data is very valuable and has enabled wide swaths of data-driven ecosystems that benefit economies and people. But sometimes, in some instances, applying pets can reduce the amount of useful information in data, and as a result, some of those benefits. To tie it back to what I discussed about sharing data with researchers, for instance, the European Digital Media Observatory noted in a recent report that one potential downside to applying pets in research settings is that it could limit the representativeness of data and, as a result, some of the generalizability of research findings. Now, as with everything when it comes to pets, exactly what that effect might be, exactly what that trade-off will look like, will depend a lot on the particular use cases. It'll depend on the data with which you're working, the particular pet you're using, the context, but it is a trade-off to keep in mind. Another tension is with ensuring equity. As I said earlier, we've talked a lot about how to develop more fairness-aware machine learning. One challenge here is that sometimes applying pets, de-identifying data, can make analyses of data less accurate for smaller, historically marginalized communities represented in those data. This was actually a primary concern with the US government's decision to apply differential privacy to the 2020 census data. This worry that it made analyses less accurate for historically underrepresented communities. And the census is a prime example of where data can be very valuable. It is used in the United States to determine a whole host of things, from government allocation of resources like education to healthcare, et cetera. So again, this tension with utility this tension with fairness here is a challenging one to keep in mind. But like I said earlier, when I referenced our work with secure multi-party computation, there might be instances in which applying pets can actually help yield privacy protective insights into equity. So again, all of this just points to the complexity and nuance in these policy areas. And this complexity and nuance really speaks, I think, to the importance of collaboration as we take these policy conversations forward. To work through all of this complexity, to work through all of these challenges, figuring out how we can best use pets, how we can incentivize the use of pets, will require collaboration and conversation between industry, academia, civil society, historically marginalized groups, and others. And we are very eager to be part of these conversations. To help in just one way, we have been open sourcing some of our tools. I mentioned earlier the work that we've done on secure multi-party computation to help with ad measurement. We have actually open sourced those private computation solutions to help other industry members develop similar tools. We have also open sourced what we call our privacy linter, which helps implement some of the privacy adversarial attacks that you heard Osama talk about earlier. And we have used that to assess our new SEER computer vision model as just one example. So we are eager for more ways to collaborate and continue these conversations, and thank you all for participating in these important conversations with us.
Well, thanks, David, for that great discussion about pets and their application to policy issues around privacy. Now, I want to talk to my colleague, Daniela Rojas, about this work, how we can think about these technologies and the development of AI in Latam. Daniela, would you mind introducing yourself before we get started?
Yes, of course. Good morning to everyone. First of all, I want to thank the organizers for inviting me to this important event and panel. My name is Daniela Rojas. I'm project manager of the Ion Resilience Lab at Imagens. Imagens is a women-led Mexican think and do tank aimed to promote the responsible development and use of frontier technologies for good in Latin America. The Ion Resilience Lab is the Imagens area committed to future-proofing society, which is being shaped by new technologies such as AI. I've been leading Imagens experimental governance, digitalization, and post-COVID economic recovery with AI systems, and currently leading the initiatives around exploring the opportunities of the metaverse in the region. Thanks for having me.
Well, thank you, Daniela, for that introduction. So in light of these emerging technical practices and the changes and development in global laws, regulations, and governance we've seen, what do both the market and the state of regulations look like currently for privacy and AI in Latam?
Thanks for the question. When we think about regulation in terms of AI and privacy, there are some countries that are leading the way, that are precisely the United States and the European Union with the GDPR, the recent AI Act, and the AI initiatives in the United States. And as a consequence, the debate focuses mainly on these countries, the perspectives and the challenges that are facing these regions. But what about Latin America? What is happening here? And it's true that the mass adoption of this system in the region is recent and therefore less advanced. That's why there are only just a few strategies and initiatives regarding AI and privacy. But it's also true that we have seen in recent years how the regional landscape is evolving. So in terms of privacy, Chile was the first Latin American country to enact a personal data protection law in 1999, so a few years ago. And since then, we have seen how many countries in the region have been developing or updating their regulation on personal data protection, such as Argentina, Brazil, Colombia, Mexico, Peru, El Salvador, just to mention a few. The problem is that some of these national frameworks do not specifically consider AI. However, in recent years, we have seen how more and more countries are implementing or are in the process of developing strategies and policies in AI, such as Argentina, Brazil, Chile, Colombia, Mexico, and Uruguay. Nowadays, we have 5 national AI strategies, while in 2020, we only had 3. I will do like a quick overview of these AI strategies. I want to start by saying that Colombia, Chile, Brazil, and Uruguay stand out for the recent AI agendas and policy. The Colombia strategy, for example, stands out because it considered an ethical framework to guide the development, use, and evaluation of AI system, being the first one to do so. And also last year, Chile launched their AI national policy that is a long-term strategy with a 10-year action plan. And that's why the 2021 Government AI Readiness Index, that is an index developed by the Oxford Insight, which ranks countries by how prepared the governments are regarding AI, spotlight Chile for its efforts on the matter. Brazil agenda is focused on tackling the country's greatest challenges in AI, including ethics. This was one of the most important events because of the importance of Brazil tech sector in the Latin America region. So if the largest tech sector have already a framework in AI, that will impact the sector like in all the region. Finally, Uruguay's strategy is focused on the public sector, specifically to strengthen skills and boost the digitalization for the public sector. These countries are also pioneers in terms of AI exploration and experimental mechanisms like sandboxes by the public sector. And I want to also mention Mexico, because it was one of the first 10 countries to have a national AI agenda. This agenda was created by Images of Oxford Insights and the British Embassy in Mexico as part of the National Digital Strategy Coordination. This document addresses the country's advantages, opportunities, and challenges in this area, as well as recommendations for the short and medium term, taking into account the different stakeholders that are important in the ecosystem. In addition to these strategies, there are also multi-stakeholder initiatives from the private and civil society sector to promote the adoption and use of AI in a responsible way. I will mention two initiatives where Images is proudly involved. The first one is FAIRLAC, that is an initiative led by the Inter-American Development Bank in alliance with public and private sectors, civil society, and academia to promote the responsible and ethical use of AI in the region. The initiative has established 4 regional hubs, which are Jalisco, that is in Mexico, Costa Rica, Colombia, and Uruguay. In the Mexican hub, the collaboration is between the Inter-American Development Bank, Images, the Secretary of Health of the government of Jalisco, and the Tecnológico de Monterrey, that is a Mexican university. The product of this alliance is the retinopathy diabetic system that supports the diagnosis of this disease, which is the principal cause of blindness in Jalisco. This is like a quick reminder of how powerful this alliance could be. And another initiative is Open Loop, that is a global experimental governance program led by Meta, which launched its 3rd program in Mexico, and I will talk more about this in a minute.
Yeah, sure. Daniela, could you share a little bit about the open loop efforts with Meta in Latam and the work we're doing together on regulatory sandboxes and policy prototyping?
Yeah, of course. As I said before, Open Loop is a global experimental governance program led by Meta that connects the tech and the regulatory innovation sector for the development of evidence-based public policy around technologies with a special focus on AI. The main objective of this initiative is to generate the necessary information for the development of governance frameworks by understanding the interaction between technology and public policy. The first program were in Singapore and the European Union. The third one was carried out in Mexico. So I'm going to talk about the Mexican program now. The Mexican program was led by Meta together with Images in collaboration with the Inter-American Development Bank, with the support of the National Institute of Transparency and Personal Data Protection Agency in Mexico. And this program was focused on how to make AI systems more transparent and explainable. What we did was to create a framework proposal on transparency and explainability. That was the first difference between the other programs. The other programs already have like a framework to be tested. And in Mexico, we create this framework based on international leading practices and tested with 10 AI Mexican companies with the support of a playbook and through personalized support with different experts, mainly from the region on the matter. So the objective was to contribute with insights, learnings, and the challenges faced by these Mexican companies through the adoption of the framework, and with that information, create public policy recommendation for regulatory institutions in Mexico. Also, we wanted to contribute to the international conversation about AI ethics and regulatory mechanisms through a practical exercise in the region with insights from the region. So we were implementing like these leading global practices in the Mexican ecosystem while also adding to the international conversation with our insights. That was like specifically important for us in Images because as an emerging topic in Latin America, there is a lack of understanding on how to operationalize AI ethics principles. So we wanted to generate precisely the necessary information for countries similar to Mexico to have more perspective than just like the European or the United States one. Just like to end my participation, we have seen how policies are falling behind in contrast to the constant evolution of AI and its impact on our everyday life. Normative frameworks, policies, and strategies take months or even years to enact. They remain a static spawn created, and in some cases, they don't even take into consideration the different stakeholders in the design and implementation of tech policies. So what these dynamic tools and methodologies such as policies, prototypes allow is helping in the design and implementation of tech policies to maximize the opportunities while reducing risks. We're about to launch a program in Uruguay focused on privacy-enhancing technologies. So stay tuned if you want to be part of the program, and it will be like super interesting to apply all the leading practices mentioned by my colleagues in the panel in the region, and also add new insights to the policy conversation.
Wonderful. Thank you for that explanation, Daniela. And thanks to all the panelists for their valuable insight and expertise. I think it's a privilege to be a part of this conversation, especially with the development of AI across the world globally. We, not only members of the tech community, but the research community, policymakers, advocacy groups, and others across the globe need to work together to figure out how we can build AI at scale based on clear and reasonable standards and best practices to ensure that we address privacy and AI-related impacts and harms in an ethical way. That way we can all benefit from these technologies. And I believe that privacy-enhancing technologies can be the future of that policy discussion around AI ethics globally in Latam and elsewhere. So thank you again to the panelists. And we can begin with a question session. Does anybody in the audience have any questions? My friends over there are going to get a microphone if they can.
Thank you. Very interesting, really. So my name is Nicolas Zingales, I'm from FGV. I have a question for both with regard to the first part, where you were focusing on homomorphic encryption, multi-party computation. I wonder how you see the privacy law dealing with this from a perspective of who is a controller, because there is no transfer of data, and so basically who is setting up this to transfer data to another party creates a situation where you might not have effective control over that data. And I wonder if that, in your scenario, in your vision about how privacy should be called a controller, somebody that does not have effective control, but some way orchestrates the way in which the decisions are being taken. So that's just a general theoretical question. And then the second one with regard to the presentation on the principles of use of AI in an ethical way. Since Claudia has referred to Mexico, Mexico has some guidelines that were published precisely about this. We will hear in the plenary session presentation by the president of the Data Protection Authority. And I wonder how you see your principles that you develop interfacing with what the government is doing. You refer to the fact that sometimes law is slower and it's not able to cope up with the faster pace of technology, but I wonder if you see a role for governments also in developing these principles, or it should be more like a bottom-up think that perhaps to be broader and include the whole region and not just focus on one national context. But I think those guidelines are very didactic and useful, so I wonder what you think about that.
Well, wonderful. I think I'll address the first question. I don't want to comment on legal interpretation of any particular legal regime and any particular position that's defined by that regime, including data processors or data controllers. But I think as we're working together to apply these types of technologies, it's incredibly important that both policy people like myself and the engineers are extremely thoughtful about the technical realities that undergird these technologies in order to make sure that they meet the variety of legal obligations that have been set out, which might not have anticipated the vast complexity of PPML-type solutions and privacy-enhancing technologies. So that might not be the best answer I can give, but that's the answer off the top of my head. I'm happy to connect you with some other folks after the panel to dive a bit deeper into that. Daniela, would you like to address a question about the governance framework in Mexico?
Yes, of course. We had this agenda that we create, but the current administration is not one of their priorities. So they launched another digital agenda to address the challenges that came out with the COVID, like the infrastructure. But this agenda does not do not address the AI. They do not address AI. So this agenda is just focused in digitalization and infrastructure. But there are a lot of civil society and private initiatives. As I said before, like FAIRLAC, and they also have this manual to evaluate your algorithm through an ethical way. So there are another resources that are not in the government, but they are helping to create a more robust and ethical ecosystem in Mexico. I don't know if that answers the question.
Well, thank you for that. Thank you for that answer, Daniela. I think we have another person over here.
Thanks. My name is Thiago. I represent the Brazilian Data Protection Authority, one of the coordinators there, dealing with topics like technology and PETs. And so, yeah, I also have double question. One might be simple, and at first I think it's intended to, but if anyone wants to contribute, I was curious if you're planning to compile these initiatives of using PETs in the context of machine learning to make some kind of report or white paper that it would be very useful for us as regulators that are trying to follow how these technologies are being used. And the other is also to Daniela. And well, since just before I was holding a panel about sandboxes and similar experience, and open loop was mentioned, I was curious to know if any of these companies that were involved in the initiative in Mexico, they were using PETs in any way, and how that was useful for the experience in this prototyping. Yeah, that's it.
Yeah, thank you. So I'll take that first part of your question. So we have put forward a lot of public information about how we're using PETs and about what we think some of the challenges that, yes, regulators, but also other stakeholders in the environment should be paying attention to. I can direct you to some of those particular resources, and I think it's important to have these conversations around what are some really fundamental topics, some really fundamental topics of terminology in this regulatory space. We'll have to do more thinking around, for instance, what de-identification really means, what anonymization really means. As I mentioned in my remarks, what exact privacy risks different PETs help to mitigate. So these are all important areas for conversation, and again, I can show you some of what we've put out publicly as well. Yeah.
Wonderful. And Claudia, would you be able to address Daniela, would you be able to address the second part of the question?
Yes, like what we saw in the Mexican program is that the companies didn't have like AI ethics or transparency and explainability knowledge. So at the beginning, we needed to fill like those gaps. Like the companies wanted to enter directly to the implementation of the framework, but only 2 companies had practices aligned to AI and ethics, because they have been in other countries focused on that, but in general, the companies didn't have practices aligned to that. For example, some companies never had tests in their system if their system were biased. So we needed to attend that first, and then start with the transparency and explainable practices.
Well, thank you for that answer. Other audience questions?
Here, congratulations for putting together the panel, and I wanted to congratulate also the panelists for their remarks. Well, I have 2 questions. First one is, I think you outlined like your concerns with privacy and building privacy and preserving AI technologies, but in my view, it seems like your concerns is most in an individual way, like or at the individual level. I was wondering if in the risks that in your assessments that you make is collective risks, right, is also considered, because I think the idea of a collective dimension of privacy or data protections is something in at least among legal scholars that is a discussion ongoing. And the second one is about are you using, is there any initiative with synthetic data? And if yes, is there any use case?
I'll take both of those. On your first point, I think you raise a really important question around how we think about risk in this space, and what risk looks like at different levels, right? We can think about risk on an individual pet level when we're talking about a pet. What does it do for an individual's privacy expectations? And this is a bit of an aside, but I think useful for this conversation. We have done some research through our organization called TTC Labs that has tried to assess what explanations of what pets do are most useful to people at the end of the day. And what that research has shown is that individual users respond most well to explanations that tie a pet not to what it does in a technical sense, but to how it changes their personal experience, right? If you tell somebody on-device learning works by creating aggregated model summaries, that doesn't really communicate much about the risk that's mitigated there, right? But if you explain it more in the way of it helps prevent data on your device going to a server so other people can't see it, that is a more useful explanation to a lot of people and gets at that individual level risk. But then you raise the point of more collective, higher level risk, which is another kind of risk we can think about in this policy space. And this is where the complexity of what exactly pets do in different use cases comes, I think, into play a lot. You have to think about, when assessing the risk of a particular kind of analysis on a particular kind of a data set, what the data are, what the pet being applied is, what the broader context is of this analysis. To give one example, some data protection schemes look to the idea of a motivated intruder test to think about the risk of re-identification. Sometimes, depending on how exactly that's formulated, that will require considering the details of who might be trying to re-identify the data, what means are available. So that there are these bigger questions of risk that come into play well, and these are all important things to think through. So I'm not sure if that fully answers your question. If you were thinking about something slightly different, let me know and I can elaborate. On the second point about synthetic data, I'm not personally familiar with what we are and aren't doing on that front, but I know, at least from a policy perspective, synthetic data is another important pet to keep in mind. But as with everything that I discussed earlier, there are some limitations and challenges to that as well that we'll want to consider carefully. So thank you for the question.
Any other questions from the audience?
How do you deal with diversity in the creation of policies and in the creation of algorithms? So from Mexico, we think about the developers as all a bunch of white people thinking about the world in some certain way and not thinking about the diversity of the world that you are working on. And how do you cope with this? I'm happy to see a lot of difference in the panel. And what are the strategies that Meta uses in order to have all the points of view in their practices?
Yes, so that is an extremely important point, especially as we think about things like how to ensure fairness in machine learning or similar topics. Having all of the voices at the table there is very important. So at a higher level, I think you heard earlier about our responsible AI initiatives, and our responsible AI has 5 pillars underneath it, kind of core guiding principles that guide what we do, and one of them is fairness and inclusion. So this means when we are out in engagements thinking about how to develop policies, we do bring everybody that needs to be at the table to the table. One great example of this is the open loop work that's done in regional communities, right? The benefit of that kind of work, of that regulatory sandboxing, is that you get those on the ground local perspectives that can say, maybe a strategy that works in one part of the world doesn't work in another part of the world because of unique aspects of that community. So it's a driving, motivating force in how we engage, and is something that's absolutely important to us.
Can I add something? What we saw in the program in Mexico is that the more diverse AI teams in terms of background and also in terms of gender were better, they implement better the framework. So the teams with not only like engineers or data scientists, but also with psychologists or anthropologists or with social backgrounds were more able to implement the framework. So that's important also to consider.
Just add a little bit more. The SEER computer vision model that we open sourced to researchers, that was trained on a variety of diverse data sets. And as I understand that model, I can share some of the research we did with you. Following the panel, that model is the state of the art for identifying globally unique experiences compared to other computer vision models. So fairness and inclusion is definitely a pillar that we enshrine as Meta thinks about responsible AI.
I already did one, so.
Hi there. Actually, I have a question. I missed yesterday the WhatsApp discussion, and there's something I'm curious about, the identification of the user with the cell phone number. The WhatsApp identifies the user using the telephone number, the mobile telephone number in the case. and that there are a lot of frauds that are possible because of that. We have the possibility of the SIM swap, and also the possibility, at least in Brazil, of the recycling of the telephone, the number, the access code, like we call it here. So I'd like to know if Meta is thinking about it, or if there's a change in the horizon, or what do you guys have to say about that? Thank you.
Yeah, so unfortunately, that's not an area that any of us on this panel really work on, and I was not at the WhatsApp session myself yesterday, but I can certainly point you to some of our local teams who are more familiar with that and could help answer your question.
Okay, thank you.
Yeah, I was actually at the WhatsApp panel yesterday. Maybe, what would be interesting is if there is any way that machine learning is used to identify fraud. Maybe that's a way to connect the two dots. But my question was about, like, more general. I think it's good as a wrapping up maybe point. So what can we do to encourage the uptake of these technologies also by small and medium companies? Because it seems that right now, yeah, you're doing a lot offering open loop and other projects that are open sourced, and this encourages certainly a lot of development, but I wonder if you think that the government should step in and create some incentive, or reform the framework in a way that makes more tangible the benefit from using these technologies.
Yeah, so absolutely, you're right. Incentives matter a lot here. As exactly you said, it's one thing for us as one of the largest companies on the planet to be able to invest as we do in pets. It is a lot more difficult for smaller and medium businesses. I talked a little bit about the tensions and trade-offs that come in applying pets. There are also lots of costs to consider, and kind of trade-offs when it comes to those costs. So one prime example of this is in the maturity of different pets, right? Some pets are newer, more or less mature compared to others. And it's often in applying those newer, less mature pets that you require a lot more resources. To give just a few examples, there might be limits on what particular computational problems a pet could be applied to. For example, partial and somewhat homomorphic encryption are really applicable only to additive or multiplicative functions. So that's one example of a limitation. There are also, limitations when it comes to how computationally intensive different pets are. Something like fully homomorphic encryption or secure multi-party computation are extremely computationally intensive, which in turn requires resources. You need to be able to invest the time, the money into building out these technologies, into perhaps reorganizing how you store data to enable these technologies to work. And then, of course, there are all of the human costs that come along with it. So incentives for small and medium businesses are extremely important here, and I think are something that need to be baked into any kind of regulatory regime that starts thinking about thinking about de-identification and how to advance the adoption of pets.
Anything else from the audience? All right, well, thank you again to the organizers and the fellow presenters at this conference and all the attendees, and thank you to my excellent panelists. I really appreciate you joining me today, and if any of you folks want to connect with us afterwards, please feel free to stop by for a chat. Thank you again.